Welcome to today's Explainer. We're diving straight into a totally vital piece of the modern cloud ecosystem, Amazon Elastic Container Registry, or, as we all know it, ECR. I've been seeing ECR pop up literally everywhere in DevOps discussions lately. So today, we're going to explore exactly how AWS manages all these containers behind the scenes. But hey, before we get bogged down in all the acronyms, let's just ask a fundamental question. How do global teams actually collaborate on massive, complex software deployments? Think about it. If a developer builds an app in Sydney, how does a server in Ohio run it flawlessly without missing a single dependency? Well, honestly, it's basically like Instagram, but for code. Seriously, when you snap a photo on your phone, it just sits there until you publish it. Just like uploading that photo for your friends to see, developers push what we call a container image from their local laptop straight up to a registry. Once it's there, servers or other devs across the globe can just pull it down and use it instantly. It's the ultimate sharing platform for your infrastructure.
So, here is our roadmap for this explainer. First, we'll meet your container registry, decode AWS ECR, compare ECR to Docker Hub, check out enterprise-grade security, and finally, push your very first image.
Okay, Section 1, meet your container registry. At its core, if you've got a package of code and dependencies sitting on your laptop that you desperately need to share, a registry is the centralized hub that makes that distribution happen. It stores, manages, and shares those images across different environments. It completely eliminates that dreaded, well, it worked on my machine problem, keeping your exact code package ready to deploy absolutely anywhere. Moving to Section 2, decoding AWS ECR. Now, we all know AWS loves its acronyms, right? Let's break this one down. The E stands for Elastic. In the AWS universe, whenever you see Elastic, like in EC2, it means AWS automatically guarantees high scalability and availability. You don't have to stress about managing servers. You can store one single image or literally a million, and you only pay for what you actually use. Next up, the C is for container. This is just the standardized package holding your application and all its required dependencies. It's the magic wrapper that ensures your app runs identically, whether it's on a local dev laptop or a massive production server. And finally, the R is for registry. This is the dedicated, secure storage locker where these container packages actually live until they're needed. Put it all together, and you've got a fully managed, highly scalable vault for your application code. Now here's something kind of fascinating. There's actually a slight bug in the official AWS documentation itself. It sometimes calls ECR a fully managed Docker container registry. And yeah, Docker is incredibly popular, but using that specific name actually limits what ECR can really do. Because as a true cloud insider knows, containers don't have to be Docker. They just need to be OCI compliant. That's the Open Container Initiative. Meaning you can use awesome alternative tools like Podman or Builda, and ECR will still gladly manage them. It's a versatile container registry, not just a Docker one.
Next up, Section 3, ECR versus Docker Hub.
This is a head-to-head matchup you'll see in tons of DevOps interviews. The core philosophical difference here? It comes down to privacy. Docker Hub is fantastic, especially for open source, but it's largely public by default. ECR, on the flip side, was built from the ground up to be private by default. It acts as a locked-down vault for proprietary corporate code. So why do massive enterprises flock to ECR? One word, IAM. Instead of the absolute nightmare of managing potentially thousands of separate external accounts on Docker Hub, ECR natively integrates with your existing AWS identity and access management policies. It saves so many administrative headaches and just seamlessly plugs right into deployment services like Amazon EKS, ECS, and Fargate. Which leads us to Section 4, Enterprise-Grade Security. Beyond just keeping things private by default, ECR really locks down your workflow. Admins can write incredibly strict IAM policies, so say a developer can pull an image, but there's no way they can push or overwrite one. It also features something called tag immutability. That's a lifesaver, honestly, because it prevents anyone from accidentally breaking production by replacing a good version with a faulty update. Oh, and it automatically scans your images for vulnerabilities the absolute second they're uploaded. And finally, Section 5, pushing your first image. Let's walk through the actual mechanics of getting a local image up into the cloud. It breaks down into 4 distinct steps. First, you log in and authenticate your machine with the AWS CLI. Second, you build your container locally. Third, you tag that image so it matches your ECR repository URI. And fourth, you just push it up to the cloud. But the real magic? That happens right in step 1 with this piped command. When you run AWS ECR get login password and pipe it directly into Docker login, it automatically fetches these highly secure temporary AWS credentials and feeds them right into your local client. You securely push your image without ever exposing a static password. It's brilliant. So as we wrap up this explainer, I want to leave you with something to think about. Look at your current workflow. Are your private containers actually as secure as you think they are? When you go to deploy your next major proprietary application, which registry are you really going to trust to guard your code? Thanks for joining me today, and keep building.